Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Dear students, welcome once again to this 30-minute session. Once again, I will be with the Senior 3 class. So it is the continuation again, and we are still looking at the unit number 7, which is the concentration of solutions. And in this lesson, it is lesson number 4 of this unit. We are going to look at the acid-base titration reactions. So this session will be followed by another session. Please, you need to follow these two, because this is the theoretical part, and we have another practical part that will be following this. So in the practical part, we'll be able to emphasize what we are talking about here in acid-base titration, because it should be a practical lesson, but I've just divided it into two, so that we go slowly and get to understand every step that we are making. Or by the time we look at the practical part, we'll be able to recall what we are supposed to do in every step of this practical, or in that practical session. Acid-base titration reactions. So by the end of this lesson, I'm very sure you'll be able to define what we mean by the acid-base titration or reaction, and you'll be able to distinguish between the end point and the equivalent point. So there are two important words that you need to remember always. Then we'll be able to calculate the concentrations or volumes of different solutions. That one will be a walkover, because we had already started the calculations. And then we look at the real-life situations of titration reactions. Where are these titration reactions applied in real life? So everything that we study in class, it is an application of the real-life situation. So we need to also to understand that one. So by the end of our session today, please, you should be able to have those ones, the 4 of them. Define the acid-base titration reaction. You'll be able to distinguish between the end point and the equivalent point. Then calculate, make some calculations, then look at the real-life situations. Still, once again, you will need a calculator. You will need a calculator, mainly a calculator. Please pick a calculator before we go on, so that you don't miss any single step of the session. Let's proceed. What is the titration? That is what we have to start with. In the titration, a solution of unknown concentration is reacted with a solution of a known concentration. An unknown concentration, a solution, so they have to be two solutions. A solution of unknown concentration reacting with a solution of known concentration. I hope I may not need this. So two solutions. This is very important. Two solutions reacting together. One unknown plus the known concentrations. So the concentrations are known. An unknown concentration with a known concentration. So two solutions, take note of that. They are reacted together. What is the purpose of reacting these solutions? Dear students, this is the reason why titration is carried out. To find out more about the unknown solution. So if you have the unknown solution, then you need to find out. You are using the known solution to find out about the unknown solution. And in most cases, this is the concentration. Actually, in this case, for the titration reaction, we are looking for the concentration of the unknown. Concentration of the unknown. So that is the purpose of the titration. So when we talk about the acid-base titration, that is the two solutions. We have said two solutions. One is either the acid and another one is the alkali or the base. So that is the solutions that we are talking about. So the titration does not only is not only carried out with only acid and base. There are some other substances where the titration is needed. So in this case, for us, we'll only consider the acid and base. Others will come later as you go on in other classes above. You'll be able to meet other types of the titration. So this first, you remember we have said one is unknown. So this can be known and this is unknown. So you need to determine the concentration of the base when the concentration of acid is known. Or vice versa, the acid is unknown and the base is known. So you want to determine the concentration of the acid using the base. So in this case, when you are carrying out the titration, one is put in the flask. You may have a conical flask. One is put in the conical flask or in the flask. Usually we use a conical flask. And another one is put into the bullet. So this is a bullet. This is a bullet. So the bullet usually has the tap over there. So this is the bullet, and this is the flask. So one is here, and another one is here. Either this one may be known, or this one is known, or the vice versa. This one is unknown, and this one is known. So you want to determine the concentration of what is here. Maybe here you have the acid, and here you have the base or alkali. So during the process, this is where we use the titration reactions I've just mentioned, is used in analytical chemistry to determine acid-base reactions or reductants, oxidation, and other species. Can also occur in reactions such as redox reactions. I said these reactions, we look at them at a later stage. So during the process of the titration, two important stages are taking place. One is the end point. So you need to note this. The end point and the equivalence point. The equivalence point. Two important stages occur, or they are reached at during the reaction. What is the equivalence point? An equivalence point in the titration refers to a point in which the added titrant, the titrant is the one which is coming from the bullet, is chemically equivalent when the titrant, you are adding the titrant from the bullet into the flask. Then the flask here, we call it analyte. So in this case, the base will be analyte, and here the acid will be the titrant. So the titrant and the analyte are chemically equivalent. Chemically equivalent. In most cases, the end point is confused with the equivalence point. The equivalence point is when the titrant is chemically equivalent with the analyte. which is in the flask. So meaning the concentrations of these solutions are equal. Concentrations of these solutions are equal. But the end point, on the other hand, is when the indicator changes its color. So during the titration, when you add the base into the flask, you are supposed to add the indicator. What is the purpose of the indicator? It changes color at the end of the reaction. At the end of the reaction. So what is the difference between these two? What is the difference between the two? The end point and the equivalence point. Usually, they are a bit confused. The end point is where the indicator changes color. So you have the indicator changes color. So we have point where the indicator changes color. And here, the point at which the titrant is equivalent to the analyte in the sample. So the concentrations of the acid and the base, that is at neutralization point. The concentration of the acid and the base are equal. That's when we say the chemically equivalent. Then comes after, when we talk about the end point, it comes after the equivalence point. So the equivalence point comes before the end point. So the end point, by the time you see the end point, when I said please, we will need to follow these two lessons all together because we need to check and see when the end point happens and then when is the equivalence point taking place. So that is the main difference. Weak acids can have only one endpoint, and some weak acids can have multiple equivalence points. So, but that one, we'll talk about it later on. So, but the main important thing that you need to remember is that the equivalence point takes place before the end point. The end point is when the indicator changes color. And by the time the indicator changes color, the reaction has already, the concentrations of the reactants had taken place and they are all equal. That will be the equivalence point. So moving on to the calculations involving moles and volumes, still you need the calculator. So you'll need that triangle, because we have used this triangle before, where we have the number of moles, we have the concentration, you have the volume. The concentration in moles per liter, that is the molality. You should remember that. And we said the concentration is equal to number of moles times volume. So if you need, we said from there, you can get the moles, you can get the volume, you can get the concentration. So you need to remember that. In a titration, 25 cubic centimeters of 0.1 mole sodium hydroxide solution is exactly neutralized by 20 cubic centimeters of dilute solution of hydrochloric acid. So you have, for these reactions, because we have said you have two reactions, you have two reactants, the acid and the base. And this, of course, gives the salt and water. What type of reaction is this? I hope you everybody still remember this. This is neutralization reaction. So you have sodium hydroxide, which is the base, reacting with the acid, which is hydrochloric acid, and this gives sodium chloride plus water. So you are asked to calculate the concentration. So you have the volume of the base, which is that is volume of the sodium hydroxide, 25 cubic centimeters. And you have the molality of the base, which will be is equal to 0.1 mole, 0.1 molar solution. Then What is the volume of the acid? The volume of the acid indicated as 20 cubic centimeters. And what is the molarity of the acid? That is what we are asked. Calculate the concentration of hydrochloric acid. So here we can calculate the number of moles. When you look at this reaction, the number of moles of the base is equal to the number of the moles of the acid. Or we can say, we can use this. We can say VB times MB is equal to, because this gives us the number of moles, is equal to VA times MA, which is equal to 1:1. The reaction ratio. So what we need to do, we need only to substitute. VB, so we can say VB times MB is equal to, we can divided by VA times MA is equal to 1/1, the reaction ratio. So what do we have? We have V, which is, this is equal to 25 times the molarity, MB, 0.1 over 20 times MA. This is equal to 1/1. Just simple multiplication sign. So when you multiply here, what do you get? So you'll get 25 times 0.1 will be equaling to 20 times MA. So you look for the MA. So what is the MA? You divide by 20 both sides. So when you divide by 20, so you remain with your MA. MA is what? The molarity of the acid, which is hydrochloric acid. So MA is equal to 25 times 0.1 over 20. When you simplify this, this is 2.5 divided by 20. Then you'll need a calculator, as I said earlier on, to place and find out the answer that you have. You have 2.5. Let us place the calculator together. 2.5 divided by 20. What do you get? 0.125. 0.125 M. Capital M, because that is the molarity. Number 2, in a titration 25 sodium hydroxide, almost this is similar question. It is only changing the values. So you can approach the same question, that number 2, in the same way as this. There is another, or we can use another method. In another method, this is, maybe this one can be simpler, or I said you can determine the number of moles here. So when you determine the number of moles, you say moles of sodium hydroxide will be equaling to molarity, that is 0.1, times 25. That's 25. Remember, the volume has to be in liters. Then times 10 to power negative 3. That is the number that will give you the number of moles. Now, after getting the number of moles, this is the moles of sodium hydroxide. So you get the moles of HCl. From the reaction ratio, the number of moles of HCl is equal to moles of sodium hydroxide, which is equal to 0.1 times 25 times 10 to power negative 3. Negative 3 is the same as dividing by 1 over 1,000. 1 over 1,000 is the same as 10 negative 3. So the number of moles are equal. The moles of HCl is equal to that. So this number of moles of HCl are in 20. So you say 20 cubic centimeters of HCl contain 0.1 times 25 times 10 to the power negative 3 moles. What about 1 cubic centimeter of HCl? This will contain 0.1 times 25 times 10 to the power negative 3 over 20 moles. But you remember, we need the moles in a liter. So that is in 1,000. 1,000 cubic centimeters will contain 0.1 times 25 times 10 to the power negative 3 over 20 times 10 to the power 3. So when you simplify this, you will find that this one will cancel with this, and this one divided by this, you will still get 2.5 divided by 20, which still gives you the same answer, 0.125. This is capital M, because it is the molarity. So these are some simple questions. So there are some the formula that you need to use. Those we have used this formula before. Or you may need to convert from volume. Like look at this. You may need to convert from grams per decimeter to moles per decimeter. So this is the relationship. We have also used this one, where we said that the molarity, which is concentration in moles per decimeter, is equal to the concentration in grams per decimeter, that is molar concentration over molar mass. So we had looked at this one. You may need also, these are the same questions. You can capture those questions and then try them, because they will also, as you practice, this is always when you are trying the question, you need the reaction. Reaction ratio is very, very important. So make sure you have a balanced equation. For example, in question number 3, you are having sodium hydroxide and sulfuric acid. So when that happens, you have sodium hydroxide, you need the reaction ratio to take into consideration, which will give the sodium sulfate plus water molecules. So this mole ratio is very important as you are calculating. So here, instead of 1:1, so you'll need either 2:1 or 1:2. So that is the importance of that reaction, of the reaction. The same reactions, you can also capture those reactions. I will not leave the homework, because this is like part of the homework that you can also use. 25 cubic centimeters of 0.1 mole sodium hydroxide solution is neutralized by 0.125 moles hydrochloric acid. So you need to calculate the constant. Here you are asked to calculate the volume, actually the volume of the hydrochloric acid is missing. So you need to calculate that. Calculate the molarity of this. Here you need the molarity of sulfuric acid. And then number 6, no, not number 6. Let us look at the real life situations, as I mentioned earlier. Where do we apply these? The titration reactions? In medicine and laboratories. So pharmacists use it to get the proper mix when compounding medicine. So when they are making the medicine, that is drugs, when they are mixing the drugs to get the proper amounts, so they use titration reaction, used to get the necessary proportions in intravenous drips. So the intravenous drips are those when they are injecting you into the deeper part of the skin, through the arteries. So they need to get proper proportions. It is crucial in surgeries to ensure correct amount of anesthesia being used throughout the duration of the surgery into the recovery. So anesthesia, that is during the operation and operating a certain area, anesthesia is used. That is, we normally call it in Kinyarwanda, ichinya. So you need to know that. Titration is also used to measure blood sugar levels to analyze blood for other diagnoses. So blood sugar level can also be determined. So those who have the sugar levels keeps on changing in our bodies. So it can also be determined by titration. Pregnancy tests can also be analyzed by the titration reactions. Food values and nutrition, those ones that may require special diets. So this is, titration reactions can also be applied. Determine whether the process complete so in determining whether the wine is ready enough for the consumption or the cheese can also be done by the titration reaction. Science in the laboratories we're always testing. So in experiments for the research, it is very important, needed. Aquarium water has to maintain the right pH levels for the fish to survive. Aquariums contain the fish that are reared for the recreation purposes. So the fish, the pH of the water in those aquariums may be determined by using the titration, because if they keep on varying, then it may cause the fish to die, or they may not survive. pH levels, as well as concentration of other elements, ammonia, nitrates, balanced out for their survival, because they have the nitrates there that the food is put in there. So those foods may contain the nitrates. So the levels, the amount of the nitrates within those aquarium can be determined by the titration reactions. So there are so many of them. This is some of them that I've been able to look at, but it is a wide range of the reaction, a wide range of the life situations where the application of these titration reactions take place. I thank you so much for this lesson. I hope we've been together and we'll be together. I said, please be there for the next lesson. That will help you to understand more of the theory that we have been talking about. So the next lesson will be a practical part. Thank you so much. See you next time. Bye-bye.